Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. As a developer, maintaining a state of flow is key to your productivity. Don't let something as simple as the wrong function ruin your day. Kite is the smartest completions engine available for Python, featuring a machine learning model trained by the brightest stars of GitHub. Featuring ranked suggestions sorted by relevance, offering up to full lines of code, and a program and copilot that offers up the documentation you need right when you need it. Get Kite for free today at getkite.com with integrations for top editors, including Atom, VS Code, PyCharm, Spider, Vim, and Sublime. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include PyCon US in Pittsburgh. Go to pythonpodcast.com/conferences to learn more about these and other events and take advantage of our partner discounts to save money when you register today. Your host as usual is Tobias Macy, and today I'm interviewing Antonio Cuni about HPy, a project aiming to reimagine the C API for Python. So, Antonio, can you start by introducing yourself?
Yes. Hello to everyone. I am Antonio Cuni. I am mostly known in the Python community because of my work on PyPy. I have been a core developer of PyPy since 2006.
And do you remember how you first got introduced to Python?
Oh yes, it was a long time ago. I think it was 2001, just before I joined the university. I was lurking on the Italian C++ news group, and there was a guy, Alex Martelli, who is very well known in the Python community as well, who kept writing about how wonderful is Python as a language. So I gave it a try and never looked back.
And so now you're working on this HPy project, which I understand is at least partially motivated by some of the pains that you felt as a maintainer of PyPy. So I'm wondering if you can just give a bit of an overview about what HPy is and how it got started.
Right, you are correct. So PyPy, one of the most painful point of PyPy is using C extensions. Most of the C extensions in the Python world are written targeting the CPython C API, and in the past years, we as PyPy developers have been trying to support all of these extensions in PyPy, but it's very painful and slow and cumbersome because the C API is too tied to the CPython internals. And so after years and years of pain, we started to think about a better way of doing the job. And we started to think that a newly designed API could be better. The problem of designing a new API is that then you need to rewrite all the extensions. So it was not clear that it was a good idea. But that's basically how and when this idea became stuck in our minds.
And so, as far as the goals for this project, I'm wondering what the overall scope is and sort of when you can state that it is done or successful.
Good question. The goal is for it to be an incremental project. We can't fix every problem at once, and so in a way it will never be finished. The goal is to start having a foundation in which you can start to experiment with, to have different backends for value implementation, and to start rewriting some extension or part of some extensions using HPy so that we can see what are the benefits. Hopefully, if the benefits are as good as we hope, then people will become interested in porting their extension to HPy, writing new backends, for example, for Cython, so that Cython emits code which is compatible with HPy, and maybe even to start experimenting with improving or evolving CPython to try new things that are currently impossible because of the current C API.
And in terms of the people who are involved in this project, I understand that PyPy being one of the main intended consumers, there are obviously people working from it there. Are there any other projects or people within the CPython core contributors or the steering council who are either contributing to it or who you have had conversations with about determining an appropriate direction for it?
Yes, HPy is a project which started from the PyPy developers, at least in terms of thinking, but other people are involved, which include many projects which are important in the Python community. Actually, PyPy started for real almost 8 months ago at EuroPython in Basel, when I met Victor Steiner, who is a core C Python developer and is now part of the Python steering committee. Talking to him, I realized that we both were concerned about the shortcomings of the current C API, and we started to talk about this new API which could solve all the problems. And we decided to sit down and start to do something more concrete. At the EuroPython, we involved also other people who were there, and in particular Stefan Benel, who is the main Python developer, and Mark Shannon, who is another CPython developer. And on the PyPy side, there were me, Armin Rigo, and Roland Lamy. And so HPy started not as a pure PyPy project, but really as a community-driven project, so that it can be useful for all the parties involved.
And for the CPython maintainers, what are some of the pain points that they're dealing with the current implementation that they are interested in working on HPy as a solution to that?
So there are many CPython maintainers. So as far as I know, not everybody is concerned about the current problems of the C API. But for example, as I said, some of the CPython developers are worried about the fact that it is hard to improve and to innovate the internals of CPython. Because, for example, given the current state of affairs, it's very hard to remove the GIL, the infamous GIL, or to use a different garbage collector which is not reference counting. In a sense, HPy will help CPython itself to try new things which might or might not be useful in the future.
And for other consumers of the C API, such as people who are writing performance critical extensions like NumPy or SciPy, what are some of the benefits that they might be able to gain by having this reimagined interface to the CPython implementation or something that's a little bit more portable between runtimes?
Well, the most obvious advantage is that you will be able to use these extensions also on alternative runtimes. For example, PyPy. As of now, PyPy for certain code patterns is by far the fastest Python implementation which is around, but you can't use it effectively with C extensions such as NumPy, which are needed for performance for other in other areas. So the most obvious use case is to use, for example, NumPy and SciPy together with PyPy and have a complete stack of software which is fast. And more in the longer term, the best benefit of HPy will be the fact that it will be possible to innovate, to try new things, to develop a new Python implementation which we can't think of right now, but it will be much easier for them to try to write a new implementation without all the pains that we had for PyPy.
And so, for people who are currently consuming the C API, what'll be the process for them to be able to take advantage of this new interface? And from the maintainer side of the CPython runtime, what do you see as being the path forward for them to be able to deprecate this old C API or at least migrate people primarily to HPy so that they can feel confident with changing what the internal API looks like without having to worry about breaking a number of extensions that are dependent on those implementation details?
So for extension users, basically they like a NumPy user, they will need to wait until NumPy is made compatible with HPy. It's not something that the user and consumers of this extension can do. For the extension writer, they will need to rewrite their extension using HPy instead of the C API, the current C API API, the currency API functions. We are designing HPy, making sure that this transition will be as easy as possible and not too hard. It must be said that currently some extensions are written manually in C, for example, NumPy. So for it, the only way of migrating to HPy is to rewrite parts of it. But most of other extensions are written, for example, using Cython. And so it means that it will be enough for Cython to emit HPy code, and all these extensions will be automatically taking advantage of HPy. It also must be said that performance is not the only advantage of using HPy. Another selling point of it is that there will be a debug mode, which will introduce many check at runtime. For example, to check that we are not leaking objects or that we are not using an object after it has been freed, and these kind of checks. And it will make debugging and development much more easier and much more robust. And this debug mode will be enabled. It will be possible to enable the debug mode at runtime, so it will not be necessary to recompile the extension to enable it, which is a pain point of this current C API.
And so for the HPI project itself, can you talk through how it's structured and just the overall development process of being able to iterate on wrapping the existing CA API and some of the design challenges that you're facing in terms of determining what the user facing interface is going to look like and something that will be clean and maintainable going forward?
One of the goal of HPy is to make it possible to do an incremental porting. So current extension will not be forced to do a port to rewrite all the code at once. It will be possible to start porting things one function, one method, or one class at a time. This is very important because it makes it possible to experiment, to try to see how it looks like, to check whether the performance is good, and to become interested in trying more, basically. And this is related to what it is the biggest issue and the biggest difficult in developing a HPy, which is to find the right sweet spot in the trade-off between writing a nice new modern API and to write an API which makes it easy for people to migrate their existing extensions. And every day in developing HPy, we see this trade-off, and we are trying various things to make it easy to migrate and to use the best practice and to design an API which is modern and safe.
And so, in terms of the interface that is consumed by the runtimes, so specifically the CPython or PyPy runtimes, what's involved in integrating HPy into those projects or any other alternative runtime, such as Rust Python, that might want to be able to provide this same outward facing interface to extension developers?
Every Python implementation will need to implement their own HPy interface, but usually it should be easy because, for example, one function will be HPy add, which does exactly the same semantics as the plus operator in Python. So if you're implementing a Python implementation, you need to have this logic inside, and the HPI is just a way to call this logic from C. So ideally, HPI will be a thin layer on top of the existing semantics, which makes it possible to call it from C. Currently, we are developing three different backends at the same time, and two of these backends are for CPython, and one is for PyPy. why do we have the need for two different backends on CPython? Well, the point is that one of the goals of HPy is that extension should not be slower on CPython. We don't want the NumPy people to port their extension to HPy and then discover that it is lower on CPython because else it's not going to be useful. So one of the backend that we have is for Python is basically a set of C macros and static inline functions which translate the HPy calls into all the C API calls at compile time. So from the point of view of CPython, these extensions will be exactly as before. And then another possibility is to compile an HPy extension in what we call the universal mode. So it produces a DLL, a .so on Linux, which is universal and it's in theory loadable and executable by any compatible Python implementation without recompiling. And we also have a universal backend for CPython and a universal backend for PyPy. And this is the only backend that will ever be needed for PyPy. And this is another advantage of HPy, the possibility of distributing one binary which works on every Python implementation if you don't care too much about performance.
So, for extension developers who want to start porting some of their code to use the HPy interface, is it something where they would include the HPy library in their source code, and then during compilation, it would then translate to whichever backend they're targeting? Or is it something that would need to be compiled into the Python runtime to provide those interfaces that would then be consumed by the library developers?
So this is work in progress. Currently, you need to manually include a specific set of headers file to compile an extension for HPy, but eventually we want to provide a nice pip installable package which you can use to develop and compile your HPy compatible extensions. So ideally and eventually people will just do something like from hpy.devel import extension and use this extension class in their setup.py file. And this class will take care of all the logic needed to compile the extension. And users will be able to decide at compile time whether to target one specific implementation, for example, CPython, or to target the universal mode, so to produce a file which will be compatible with everyone.
And you mentioned that there are two different backends for CPython because of some of these performance considerations. So I'm curious what you have seen as some of the observed or potential impacts on performance and runtime overhead for using HPy in that universal mode.
Yes, that's a very good question. First, let me explain why we expect the universal backend to be slower than the CPython specific backend. For example, in CPython, you are using reference counting, which means that every time you pass an object around, you need to call incref and then decref on it. And in CPython, these calls are usually macros, and so the C compiler can optimize it very well. In the universal mode, there are no longer incref and decref. We are using the concept of handles, which are more opaque. And since the implementation is universal, it cannot be written as macros. It needs to be function calls which are resolved at runtime when they are loaded into the proper interpreter. So, for example, it means that every incref and decref inside the extension module will become a function call instead of a macro. That's why we expected it to be slower in the universal mode instead of the CPython specific mode. But actually, we have a benchmark which shows that this impact is much lower than we thought. So the first benchmark that we tried is to port the UltraJSON library to HPy, and we measured that the CPython backend has no impact overhead at all. So UltraJSON HPy is as fast as the normal UltraJSON on CPython. And on CPython using the universal backend, this benchmark is just 2% slower or so, which means that for most projects, this might be good enough. And the advantage of being being able to distribute a single binary for all the implementation might be bigger than the disadvantage of having a 2% slowdown, of course. It must be said that this is just a single benchmark. We need more benchmarks, more extensions, and more measurement before knowing precisely what it will be the actual impact.
As you have gotten further along in this project, what are some of the ways that the initial vision and scope of the project has been updated, or any assumptions that you had going into it that have been changed or modified in the process?
So far, I think that we are mostly on track in the sense that the project is going more or less in the direction that we imagined when we started. One of the things that we realized is that the C API is very broad. We already knew it, but we knew from the point of view of people that wants to implement its semantics. Now we are also seeing it from the point of view of people who wants to use the API for doing stuff. So we are realizing there are many different use cases for which people needs to use the API and the existing API. So we need to design a new API which makes it possible to implement all these use cases.
So, in terms of the timeline for this, what do you anticipate as being the amount of time that's required to get this to a point where library developers should start using it as the target for building their own work? And what do you see as the path forward for the CPython implementation as far as adopting this as at least an optional interface for the core runtime?
So for now, the project is still in its very early stages. We are still busy implementing the very basic stuff. So for example, as of now, it is not yet possible to write a custom type. You can just write functions. So it's clear that it's not immediately useful and usable for writing the real extensions. The How much it will take to put it into a state which is useful, well, I don't know. It mostly depends on how much time we can spend on it, which also depends on how much money we have to work on it. Basically, I hope that in the following in the next months we should be able to arrive at the point in which we have a small NumPy-like library which shows all the interesting and hard parts, and then we can use this as a benchmark and as a starting point to go forward and, for example, to start experimenting with the real NumPy. What was the other question? Sorry.
Just curious about the timeline for the project and any plans or projected timeline for HPy to be available in the core CPython runtime as at least an optional interface.
Yes, I don't think that this is going to happen anytime soon. I can imagine an ideal world in which all the current C extension will be written using HPy, and so CPython will be able to decide to use HPy as their official interface. But I don't think it's going to happen anytime soon because it will involve rewriting many parts of the internal core. What could happen and what I hope it will happen is that people could try to fork CPython to experiment. So, for example, I can imagine that once HPy is stable and used, and uh, and uh, and you know how it looks like, I can imagine to fork CPython to remove many unnecessary, well, not unnecessary, but not vital modules, and start to re-implement the internal CPython objects in terms of HPy API. And then once you have these, you can start to experiment with improving the virtual machine of CPython itself. For example, you can try to use a garbage collector instead of reference counting, and things like this. But as I said, I think this is more in the medium or long term than the short term.
And as you have been working on HPy, what have you found to be some of the most challenging or contentious aspects of the project, or any long running design questions that you have had to go back and forth with the other members of the project?
As I said before, the biggest challenge is to find a sweet spot between make having a nice API and make it easy to port existing extensions. So Many times we sit down in front of a blackboard or in front of an editor and we try to sketch how a C extension looks like, how to implement a type, how to pass pointers which can be moved in memory by the GC and etc. And every time we spend hours, really real hours, discussing maybe two or three different possibilities, and possibility A is closer to the current Python solution, but maybe a bit more inefficient for PyPy. Possibility B is maybe better for PyPy, but harder for C users to write. And then there is a lot of trying around until we find something which respect all of the requirements, basically.
And when you're commenting too about the possible transition period of HPy, it starts to bring up echoes of the Python 2 to 3 transition. So I'm sure that there are a lot of concerns on that line as far as not wanting to fork the community because of this potential new interface, even though it will likely have significant benefits downstream.
Yes, you are completely right. We want to avoid any split in the community, any fork, and anything like that. That's why earlier I said that one of the goals of HPy is to be incremental. You will be able to take, for example, NumPy and start rewriting just one method of it using the HPy interface and keep using the old API for all the rest of the extension. And this new method will be fast on PyPy, for example, and there will be no difference for CPython. So with this starting point, it means that you can always improve and make things better, for example, for PyPy, without making it worse for CPython. And the more you do, the better things become, and then hopefully at some point HPy will get enough traction that people will want to use it to get the benefits.
And what do you see as some of the potential risks to the success of HPy or any blockers that might come up that will prevent any forward progress on it?
The biggest risk is that many projects don't want to change. So, for example, from the point of view of NumPy developers, why do they want to accept maybe our pull request to migrate slowly to HPy when their existing code is perfectly fine for the existing users? I can't answer to this question. I hope that the community as a whole will see that HPy is needed to make it possible to innovate in the Python world. Maybe I didn't make it clearer earlier in the interview, but the biggest problem of the current C API is that it makes it hard or impossible to innovate. Python as a language is doing a good job because of its big ecosystem with all the libraries, and people expect all the libraries to be available when they use Python. But all these libraries are very tied to the current internals of CPython. For example, the fact that they have reference counting and that at offset 8 of, of an object there is a field which is the reference count, and so on. These low level details which makes it impossible for new virtual machines to innovate and to try other things. If Python as an ecosystem does not try to evolve and to innovate, it will be the risk is that it will be become less and less relevant in the future. The GIL is already a perfect example. There have been many attempts of killing the GIL, removing the GIL, but reference counting is a big issue to it, and it is not possible to rewrite CPython without it because of all the issues that I mentioned before. So from side point of view, HPy is good and needs to happen for the whole Python ecosystem, not just for PyPy. PyPy is just the main benefit immediately, the main immediate project which can benefit from it. But generally speaking, the possibility of having more virtual machines and runtimes is something that you really need. as a language, as an ecosystem.
And I can definitely see that as being a potential path forward as well for solving some of the issues that we have in being able to target mobile platforms or the web as well, because as you said, the majority of Python is tied to the CPython runtime, where once we get to a point where we can innovate on the VMs or have multiple different deployment targets for it, it will unlock some of the potential for being able to run on some of these platforms that we're currently unable to target.
Yes, I completely agree, basically, yes.
And so, in terms of the near to medium term for HPy, what do you have planned?
Most immediate target is to be able to support custom C types in extensions, so we can experiment with NumPy like extensions and see how it looks like and what is the performance. This is something which is going to happen in the next weeks, basically. And then the other big plan that we have in the short period is to write a Cython backend for HPy, so that people writing extension in Cython will be able to immediately benefit of it without having to rewrite anything manually.
In terms of any help or contributions or support for the project, what are some of the most useful skill sets or ways that people can help to move the HPy project forward?
That's a very good question. Of course, any help is welcome. I think it would be very welcome to have someone who is a consumer of the C API, someone who writes C extensions daily or who has a lot of experience in writing it, because it could it could very it could be very useful for us to be warned beforehand that this direction that we are taking is wrong or that direction is better, and things like this. And then it's already nice to see that HPy is attracting interest from various projects and parts of the community, because we started in a few people, but immediately we got manifestation of interest from developers of Rust Python, so that they could load their HPy extension on their runtime. Graal Python, which is another Python implementation based on Java and developed by Oracle. And recently, there is also a sub project to be able to use HPy with Rust, so that you can write a Python extension in Rust and decide whether to target CPython or HPy. So we have users and people involved from both ends of the line. From in one end, you have people writing extensions, and on the other end, you have Python implementation. And any people who have experience in these two topics is very welcome to help.
And are there any other aspects of the work that you're doing on HPy or the goals that you have for it, or some of the potential impacts and benefits that we didn't discuss that you'd like to cover before we close out the show?
Sorry, could you repeat, please?
I was just wondering if there's anything else that you think we should talk about in terms of the work you're doing on HPy, or any of the potential benefits or impacts that it might have, or any of the related projects that will benefit from it.
Not more than I already said.
Okay. Well, for anybody who wants to follow along with you or get in touch or contribute to the HPy project, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the poetry tool. I've started using that more heavily in some of my projects, and I've been enjoying that as a way to get things set up quickly and managing dependencies. So definitely recommend taking a look at that for any new projects you're working with. And with that, I'll pass it to you, Antonio. Do you have any picks this week?
Yes, I would like to suggest a book which I read recently, which is Collapse by Jared Diamond. And I think it's a book which is interesting and terrifying from some point of view, but I think it's good to read it to have an understanding of what's going on in our world, keeping in mind what happened already in the past.
I'll definitely have to take a look at that. So thank you for the recommendation, and thank you for taking the time today to join me and share the work that you're doing with HPy. I'm definitely excited to see how it goes and see some of the downstream benefits from that. So I appreciate all of your work on that front, and I hope you enjoy the rest of your day.
Thank you very much, and goodbye.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.